Hello, my name is William Rinker, the lead mechanical engineer on the project for Sensor Technologies to produce a flammable gas detection sensor. We took the route of making a 3D printed housing of PETG. It is a two-piece housing. The circuit boards are mounted to the bottom, and the top encapsulates the parts of the circuit board that extend past the bottom half of the housing. The gooseneck attaches to a extension inside of a heat press inserted threaded insert, and through here wires run to our sensor. You see we have three buttons on the face of the device. We have a power switch, and then we have our conversion from ppm to LEL, and this button to clear the sensor. On the bottom we have accessibility to the charging port, and we have a window to view our charging indication lights as well as our screen to show the ppm levels.
Alright, so from an electrical standpoint, so our power switch is going to be this switch right here. This will start the whole microcontroller and the device up. You'll first be prompted with a warm-up stage. Now this stage is about 1 minute, as it takes a while for the sensor to come up to temperature. Now we're talking about that. We also have a calibration mode for this device, as the sensor needs to be calibrated every so often. So what you do when the sensor is fully warmed up, you'd press both of these buttons at one time, and you'd be put into calibration mode. Then you'd put 2.5% LEL gas to the end of the sensor and hold it there, and do so until the time runs out for the calibration, and then the sensor will be fully calibrated, giving accurate readings. As we can see on the display, we have our max ppm at the top, and like Will said, this can be reset with this button right here. We also have a nice readout of the ppm, nice and big for users to use, and then hitting that right button will then switch to LEL, and then the top it says max LEL instead of max ppm. Now moving on, we can demonstrate how it reacts to gas. So putting some of the 2.2% LEL gas on the sensor, we can see that ppm will rise, and there's an audible chime letting you know that gas levels are rising. And as you can hear, the tone does change as the gas level rises and as the ppm levels rise. Now moving on to the calibration side of things, the way that works is you press both of these buttons and you get a countdown. It says calibration in 15 seconds, apply gas now. So what we do is you apply an end to the housing. We don't have that housing, but you apply the gas to the end and hold it there until it says it's complete. So right now it's calibrating. It is taking the input voltage from the sensor and then sets an offset. It'll come back down as soon as the gas dissipates in the sensor area. Now one feature, excuse the pause while the buzzer goes down. One feature of this for charging, as is shown before, the port is on the back, and that LED right at the top will light up green when it is charging, and it will light up, or then it will stop lighting up as soon as it is finished. And then wrapping it up to reset that max LEL, or ppm as I should say, back to 0 right there, so the user can get the max readout when they need, and then also set it back to 0 when they want. And then to turn the device off, just simply flip that switch.